Good afternoon, esteemed colleagues. I am Aleksandr Voitenko. I represent Kadasrtsurvey. We live and are based in Irkutsk. A few words about what we do. The main lines of activity are digital aerial photography, mapping, creating maps, designing, and cadastral work. A lot has been mentioned today about UAVs. The vendors, distributors, accuracy characteristics. We also heard a lot from software developers, what you can get from this technology. We have been looking at it for a long time. It has become very relevant. So I would like to compare dots captured by a UAV. I mean, it doesn't matter, with dots captured from a laser scanner. Since 2008, we had two high accuracy sensors, Leica from Canada and a Swiss center. We also have our own aircraft tailored to photogrammetric needs. We selected a small area, about 100 hectares, where we did laser scanning, aerial laser scanning. So this is a digital elevation model. Aerial laser scanning was captured from 370 meters. It took about 6 minutes. GSD is about 4 centimeters. Number of points per square meter is 26 to 30 per 1 square meter. The next stage was getting digital orthophoto plan. This is 1 to 5,000. Scaling up 1 to 2,000, 1 to 500, and 1 to 200 and 1 to 100, just to see what kind of GSD we have. Also, we purchased the cheapest UAV, a drone, Phantom 4. You know what technical capabilities it packs. So we did the same test area with 80% side and 80% forward overlap, pixel 4 centimeter, GSD 4 centimeter, surveying time 5 minutes. So this is a digital surface model. This is how it looks. I'd like to say up front that tachymetric imaging was our reference point. So we had a lot of ground control points. We had a lot of control points and very good plan and elevation data. So we started generating orthophoto plans based on input data, Photomod Light, Argsoft, and others. We were not interested in software per se. We were after accuracy. So this is the same area blown up. As you can see, it didn't work very well with elevated buildings. Roofing begins to blur. You lose clarity. It may not be a factor of camera, it's the approach that may be faulting. Then we used TerraSolid to dissect both point clouds, laser scanned and photogrammetric, and compared them. Here you can see that on the left is laser scanned, which is less dense. On the right is photogrammetrically processed, more dense. The plan and elevation characteristics are identical. A little comparison of technology. Our output requirement was 1 to 500. So we do get 1 to 500. With the UAV was 100, laser scanning 370. So you can see the image side, overlap information, and time spent on mission. What are the characteristics? Point density 26 to 30 per square meter, and automatic photogrammetric density is 1 to 1700 points. This uneven density has to do with the processing technology. The absolute accuracy, according to laser scanning, is 7 centimeter, and in automatic mode 6 centimeter in plan and 9 centimeter in height. There is one big if in this technology, that is getting vegetation DSM. In a lot of towns there can be a lot of green areas, so we generate a profile for that area, and we can see that under the canopy we get information in full amount, and with photogrammetric technology this data will not be captured, meaning you'll have to send a team on the ground to do land survey to collect additional points to generate correct orthophoto plan. Both technologies, in our opinion, at this stage allow to get 1 to 500 digital maps, digital plans. Based on them, you can create digital orthophoto maps, DSMs, but you will have to do additional groundwork, field work. Some enterprises claim that don't have to go into the field or on site, they do it at their desk, but we believe it's not possible. It is our opinion that automatic photogrammetric processing of data captured by UAVs is a good technology for open, vegetation-free areas. In cities, it's more challenging to use it because there are a lot of trees. Or it works during autumn or springtime when leaves are off or buds haven't burst out yet. But it has to be supplemented with field work. One of the biggest advantages with the photogrammetric processing is quick visualization of voluminous data. This is Aleksandr III monument, who founded, one of the founders of Siberia. It took us a couple of hours to generate this. We flew a mission, and this is what we came up with 2 hours later. 23 million dots. This picture was borrowed from Viktor Adrov. It's very visual. So we wanted to revisit the topic of models. They are quickly built raster models. Both on laser scan data and on photogrammetric points, you can get quick models without human interference, and bigger models too, which require a lot of human attention. This is Irkutsk river embankment. So 3D visualization of the city can be done very quickly with photogrammetric automatic processing. Also, we did a vector-oriented model early in 2013 for the city of Irkutsk, the city of Krasnoyarsk, I'm sorry. Input data was laser scanning data. It was a labor-intensive project, time-consuming. Each building was drawn in photo mode and then textured through aerophoto imagery. You can move buildings around, add buildings, and delete. That's all I have. Thank you very much. Большое спасибо. Вопросы? Here's my question. I'm from Center of Geodesy and Cartography. 23 million dots model. How much storage takes up? A picture from Phantom 4 camera. No, a model itself. How much storage takes up? Plus the texture. For each point, 300 megabytes, not more. This has the highest detail. I'm trying to be specific. 23 million. It will take up 300 megabytes, not more than that. All right. And my second question, the vector model, can you call it up textured using photo mode software? I forgot to ask this question to Viktor Nikolaev, so I'm going to direct this to you. The texturing, I mean the texture that it laid over building, is it done automatically? It's not done automatically, but well, speaking about this technology, it was received through combined method. All 3D objects were built with photo mode, and we use telephoto for texturing, and it uses automatic textures. It does everything automatically. It looks for an image from which to borrow. Yes, it's self-searching. Okay, got it. I got it. Я думаю, ваш вопрос связан также с тем, преобразовали ли его в модель. No, my question. No. Мой вопрос. Для меня это также модель поверхности. Не облако точек, а модель. Но не сетка. Но это и сетка. Если связать все точки, получится сетка. Только углы домов и так далее. Немного точек. Не все нужно связывать. Но здесь нужно больше, потому что все может усложниться. Это не кровля дома, правда же, которую можно 6 точками соединить. Можете векторную модель. Меня интересовало, нужно ли это делать в ручном режиме или автоматизированно. Ну, в ручном режиме слишком много времени уйдет. Thank you. Я как раз этот вопрос хотел задать и предыдущим выступать. По собственному опыту, большая часть пользователей, археологов, им не нужны облака точек, им нужна векторная модель или цифровая модель местности, как ее ни называй. Это, конечно, нужно обсудить. Сколько времени потребуется для перехода от облака точек к модели поверхности? И вопрос был, может ли фотомод этим заниматься, выполнять это. To address some tasks, a DSM represented DSM will be enough. I mean, we don't need a vector model for some applications. For example, designing GSM stations, they don't need vector models. DSM will be enough. So it could be a lot of labor costs, all to nothing. We quickly visualize a settlement, we looked at elevations, and those cellular operators will find it enough. With vector-oriented models, well, you could use it for, you can add some semantics, do deeper analysis. Then you need more expensive models. Both technologies have the right to be. They address different tasks. Ну а как все-таки от облака точек до векторной модели? It's just that they don't do vector models from point clouds. You mean us? Вопрос, нужно ли делать? Как перейти от... The way you explained it, apparently, in the first case you vectorize it manually. In the latter, or did you start from point cloud? You can go do both. TerraSold can allow you automatic sorting, and then you edit. But where do you get roofs from? A roof is kind of flat, I mean, if you look at it from above. So it did calculate. So that was the question, how much time will it take to turn a point cloud into vector model? I think a couple of years. Because for laser scanning, you already could do it.